let me give you a brief introduction to explicit differentiation and implicit differentiation. So look to your left. Explicit differentiation, so when you see a function or equation, usually the equation is y is in terms of x or x is in terms of y. What does that mean? Y is in terms of x means you have y equals to some x. So y is on one side. There is no exponent for y. So y is just 1y and then equals to a bunch of x and constant on the other side. So that is y is in terms of x. How about x is in terms of y? So simple, you have x on one side, no exponent, nothing else. So you have x equals to a bunch of y and constant. So this is x is in terms of y. So for explicit differentiation, you have y in terms of x or x in terms of y. When you do differentiation, so you simply take the derivative on both sides, or you can just call on the left hand side, you call that a dy dx, the derivative of y with respect to x. So since you say with respect to x, then you are treating x as an independent variable. So for the first one, you bring the phi down. 2 times phi is equals to 10. So x raised to the phi minus 1. And then bring the 4 down. So you have 12. 4 minus 1 is equals to 3. And then the other one, x is equals to 3y squared minus y to the negative 1. Dx dy, so you are taking the derivative of x with respect to y. With respect to y means you are treating y as an independent variable. So you bring the 2 down, so you have 6y to the first power. You bring the negative 1 down, you have negative minus 1, so that gives you a plus. Negative 1 minus 1 is equals to negative 2. So this is explicit differentiation. So how about implicit differentiation right over here? So for implicit differentiation, so in this case, you are not able to isolate y or x on one side. All right, so what happens if you are not able to isolate x or y on one side? So in this one, we have a bunch of y and then x, right? So are you able to do this? Are you able to do y equals to some x? Can you do that? I'm asking you to do this. Can you do this for me? So you have an equation, y to the 10 plus 3y to the 4th minus 5y to the second, whatever the rest is. Are you able to write the equation like that? Y is equals to some x. The answer is no, right? So this cannot be done. So this cannot be done. Or what if I don't even want to do this? Can I just get an equation? I don't care what's on left side, what's on right side, and then just do the differentiation. So that is what we are trying to do next. So for implicit differentiation, I am not going to waste any time to write y equals to some x or x equals to some y. Okay, I am not going to waste any time to do this. So whatever is given, I will start the differentiation right away. So we have y to the 10 plus 3y to the 4th minus 5y squared and then plus x squared equals to 20. So what we are going to do next is we will go straight to the differentiation. So I am going to differentiate both sides with respect to x. So the next line right here is I differentiate both sides with respect to x. So simply do a dx on both sides, the derivative on each side with respect to x. And then on the right hand side, the derivative of 20 is equals to 0 because 20 is a constant. And then on the left hand side, we have 4 terms, right? So that means you are taking the derivative of every individual term. So now, when you comes to the first term, so let me use another color to explain this. You have d dx y to the 10. What does that mean? That means you are taking the derivative of that term with respect to x. So that leads me to the first problem in implicit differentiation. Hey, you are taking the derivative with respect to x. So that means you are treating x as an independent variable. But in this derivative, you have y to the 10. So there is no x for you to differentiate. So what is that equal to? So here is how implicit differentiation works. So in this problem, can you write this down for me? So I want you to treat y as x. So treat y as x. And then you take the derivative. And then write dy dx at the end. I will explain what that means in a minute. So dy dx at the end. I want to write this down because every time you encounter this situation, I want you to say this to yourself. All right, write this down. every time you encounter this situation. What situation? You are taking the derivative with respect to x, but there is no x in that term. So here. Now, so you have d dx, right? And then y to the 10. There is no x in here. So what should I do? Now, here is the first step. And this, I usually call this a hidden step. This is hidden in implicit differentiation, but people just don't write this out. So that step is, you are doing a d dy and then y to the 10, right? Treat y as x, you have to differentiate the y to the 10, and then I wrote a d dy, that means I am treating y as an independent variable. And then you are going to ask me a question immediately, hey, how can you change the dx to a dy? There is no way you can do so, right? Fine, okay, I'm going to write one more thing. I'm going to write dy dx. Now, do you see that there is a dy over here and then a dy over here? So what if you cover those two up? What do you have? If you cover those two dy's up, do we agree that we have dy to the 10 and dx? And also, do we agree that we are back to a d dx? So it looks like we break the d and the dx down into two different fractions. One, the d, when the d is on top, we have a dy on the bottom. When dx is on the bottom, we have dy on top. So if you just cover up those two dy, we just have a d dx and then y to the 10. So now, what is that? What is this? d dy y to the 10. So this is a simple power rule. So that is 10 y to the 9th power, right? So what's left? So take this, gives you 10 y to the 9th power, and then the rest is just a dy dx. What did I ask you to write down? Read that to yourself. You treat y as an x, take the derivative, and then write dy dx at the end. So that means when you encounter this situation, d dx y to the 10th power, when there is no x for you to differentiate, and then you only have a y, so all you have to do is, listen, you do the power rule anyway, whatever rule that is, that implies to all the function, exponential, logarithmic, and then trigonometric function, whatever function that is. So you treat y as an x. So you apply the power rule or chain rule, whatever rule that is, you treat y as an x. So that means you do the derivative anyway. So after the derivative is done, put a dy dx at the end. All right. So the first term is take the derivative using implicit differentiation. You get a 10 y to the 9 and then dy dx. So let's continue. So we have so many terms, right? So what's the next term? So the first term gives you a 10, right? Oh, let me go back to yellow. So we have 10 and then y to the 9 and then mark this dy dx. And then the next term, we have 3y to the 4th. So you bring the 4 down. So I am doing this term right now. You bring the 4 down. So 3 times 4 is equals to 12. And then 4 minus 1 is equals to 3, just like power rule, right? So you bring the 4 down and then take 4 minus 1 and then mark this dy dx. And then the next one, bring the 2 down. 5 times 2 is equals to 10. 2 minus 1 is equals to 1. And then mark this dy dx. And then the d dx, so I am talking about this term right now. So this is just the derivative of x squared with respect to x. So that is just equals to 2x. There is no need to mark the dy dx because this term is just like an explicit differentiation. You are taking the derivative with respect to x, and x is the independent variable. So there is no need to mark dy dx. And then you have equals to 0. Are we done? We are almost done. So the last step is, I would like to isolate the dy dx on one side. So what we are going to do first is I am going to toss the 2x to the other side. And then for the rest of the terms, I am going to factor out a dy dx. So factor out a dy dx, and then inside this square bracket, you have the derivatives right there, and then plus 12y to the 3rd minus 10y, and then at the end of the day, all you have to do is divide the square bracket on both sides. So now the conclusion or the result is dy dx, and then you have negative 2x divided by 10y to the 9 plus 12y to the 3rd, and then minus 10y. So that is your final answer. So this is the final answer of the given function. So we just differentiate the given equation right over here using implicit differentiation. So with a little bit of practice, we can do this pretty fast. So let me change this to another color. So let me just give you another example. So let's say x squared minus y to the 20 equals to 6. So this one, if you differentiate both sides, so you have x squared minus y to the 20, and then you differentiate this side, right? So this one, you can just go straight to the next line. So the first term has x only, right? So you have a 2x. And then the second term, you bring the 20 down, and then y to the 19. So since this is a y, and then we are doing this with respect to x, then if we have marked this with a dy dx, and then the derivative of 6 is equals to 0. And then you toss the negative 2x to the other side, so you have negative 20y to the 19, and then dy dx, you have a negative 2x, right? So the negative side got cancelled. So now you have dy dx equals to negative 2x, or I should use a positive 2x divided by 20y to the 19. This is your final answer. And of course, you can simplify the 2 and the 20. All right, so this is the brief introduction to implicit differentiation. If you find this is helpful and easy to understand, give me a like, share the video for me, click the subscribe button if you're new to the channel. I will catch you all in the next video. Signing out.